Unit 1, Lesson 3, what will be the EK mascot? Today we're going to be investigating dot plot, bar graph, segmented bar, and the mosaic plot. All right, so for this one, it gave you a particular graph and it went ahead and asked you to make the graph. So the first thing that you should have done, you can't make this graph on your calculator, but it's not a big deal to go ahead and just make it. So this is a bar graph, a relative frequency bar graph. The one that we've done before was a bar graph that had a frequency and just had the numbers, but this is using the percentage. So it was asking which is the most popular mascot. So amongst teachers, we have this is my graph, students was my graph. And then we're gonna continue to answer these questions. Just looking at the graph, which one looks like they're gonna be more popular? Well, if you notice, it looks like teachers are 80% for RAMs and 30% for students, so that's 110% if we're looking at percentage. And then Falcons is 60% and 10%, so 70%, and then Prairie Dogs is 10 and 10, which is 20. So just looking at the graph, it appears that it's RAMs. However, we also know this is just percentage, and this is why you have to be careful and not compare percentages or combine percentages without knowing the totals. And that indeed is the issue here. And I have that there's only 100 teachers and there's 500 students. And when you multiply the percentage, 500 times 30%, because it tells me 30% of the students are RAMs, right? That only comes out to 150 students, where 500 times 60%, and that's how many wanted the Falcon, and that's 300. And so when you look at the totals, you actually see that the RAMs were 230 total, and Falcons were 310. So it showed that the Falcons actually was bigger than the RAMs, and we were misled because the original aspect only had percentages, and I had a lot more students than I had teachers. So what I do here, which you might have caught a glimpse of it, is a mosaic plot. And you can see the reason that I have students as 5 bars, it's because I had 5 times the students than I had the teachers. Now in a mosaic plot, you don't typically have them completely apart this way. You actually have them smacked together. I'm gonna show you like this. So this would be like a mosaic plot. The students and the teachers are together. This one is a different one showing intro to stats, what classes yours your favorite, or what's your math class, what's your favorite math class. And you can see pictorially on a mosaic plot which group is the largest group. Because students are 5 times as wide, you can easily look at the dark blue area, and the dark blue area of the students and the teacher combined looks like it's the most favorite, which is AP Statistics. And then it looks like the least favorite class looks like Intro to Statistics, which is kind of the pale orange color. And I can just look at that by looking at the area. And this is just visually, it helps me decide it. But I do have them smacked together. In my graph that we're doing right now, we don't have them smacked together because we were just putting a segmented bar and then we were actually expanding it. But yes, you'll want to smack them together so that you can see, oh, look, we now can see the picture and you can see that, oh, wow, the red is clearly more area than the blue. So that's a mosaic plot, and the whole point of the mosaic plot is to be able to see the population of the survey, of the people that took the survey, and not just the initial percentage. Remember, percentages, I can make conclusions like this. More teachers, this is teachers, more teachers like the Rams and the Falcons. But I cannot say more teachers like the Rams than students like the Rams. Because when I look down here, look, there's 150 students that like the Rams and only 80 teachers, because this is a percentage. And I only have 100 teachers and I have 500 students. So you cannot make conclusions if you only have the percentages across different categories. You can only make conclusions within the categories if you're given percentages. Now, obviously, if you're given frequencies, you can make conclusions everywhere because you know the exact number. Okay, and I believe I went ahead and just answered these other questions in what I was saying. Here's the notes that you would want to do. Learning target 1 and 2, the displays for categorical data that we've discussed so far. We have the bar graph, and each bar graph represents frequency. If I do percentages, it's relative frequency for each category. Then I have a segmented bar graph, and the segmented bar graph is the one that I stacked up to make 100%. And that was this one here, where these are segmented bar graphs. The one on the right, Then I made the mosaic plot, which is obviously segmented bar graph, all stacked up, but also the width regarding the population. The association, remember, let's look at if there's an association. Is there an association? Let's look at the segmented bar graph. Just look at that part here. Is there an association between if you're a student or a teacher and which one you like? Well, obviously there is, because the students clearly like the Falcons way more than the teachers. So if there's an association, remember that the bar graphs are different. The percentages, the frequency bar graphs, the segmented bars are different, and they are not independent. All right, for check for understanding, you're going to go ahead and evaluate this mosaic plot, and it shows you the different, A shows calculate the proportions of juniors that are currently working, not working, but have never had a job and never, have a job, not working, but have had a job and never had a job. And for those, you can look at currently working only of the juniors. So there's 51 juniors. So this is conditional relative frequency, because the condition is they are a junior, and the denominator is junior total junior. And so each one of them, the denominator, as you can see, is 51. And the second one was for all the seniors, and there's a total of 80 seniors, and the denominator on each of them is 80. So it says, write a few sentences summarizing what the display is about the association between grade level and job experience. So you can see that, look, there's an association between grade level and job experience, because you can see that the percentages are different. You can see that nearly, in each of them, nearly 38% of seniors are currently working, where only 27% of juniors are working. Nearly 50% of seniors are working, are not working, but have had a job. And only 43% of juniors are working, but have not working, but have had a job. And only 13% of seniors have never had a job, and 29% of juniors have never had a job. Because those are so different, all the percentages are so different, you can say that there is an association between grade level and if they've had a job, what their current job employment status is. So because these bar graphs are different, there's an association between grade level and employment status. If they were the same, we would say they're independent. There is no association. And it doesn't matter if I walk into a room of juniors or a room of seniors. If I randomly chose someone that have never had a job, I will have the same chances in both rooms. And that clearly is not true. All right, thank you for listening, and we'll see you next time.